Hi, welcome back. In the last video, I discussed how to normalize a quantum state. Once we have our quantum state normalized, we are ready to calculate the probabilities involved. For example, suppose we have our first quantum state, ket psi1, that we have already normalized in the last video, 3/5 ket plus 4/5 ket minus. We can ask ourselves which will be the probability of finding spin up or spin down for a measurement taken on this quantum state ket psi1. The probability of finding spin up is given by this expression, p plus, where this sign plus refers to the spin up module squared of this inner product. Let's consider here a ket psi subscript I, which is a general quantum state. On the other hand, if you were interested in calculating the probability of finding spin down, we have to do in a similar way through this equation here, p minus equal to module squared of this inner product. Let's apply these two definitions our case for the quantum state ket psi1. So first, let's find the probability of find spin up if a measurement is made on the quantum state ket psi1. So first, I'll calculate this inner product, bra plus ket psi1. So that's a simple calculation. We just put here bra plus, that multiplies 3/5 ket plus 4/5 ket minus, and multiply term by term here, and we have 3/5 bra plus ket plus 4/5 bra plus ket minus. As we discussed before, this must be equal to 0 and this term here equal to 1, and it brings us to 3/5. If we plug back the result of this inner product into our definition for the probability of finding spin up, we end up with 3/5 squared, which is 9/25. So that's the probability of finding spin up if a measurement is made on the quantum state ket psi1. Similarly, we can calculate the probability of finding spin down. So I'll do the same. I'll start by calculating the inner product, bra minus ket psi1. Here we have bra minus, that multiplies 3/5 ket plus 4/5 ket minus. So if we multiply term by term here, we have 3/5 bra minus ket plus 4/5 bra minus ket minus, and as we discussed before, it should be equal to 0, it should be equal to 1, and we end up with 4/5. Then the probability of finding spin down, if I plug this value back into this module squared here, we get 4/5 squared, which is 16/24. So that's the probability of finding spin down if a measurement is made on the ket psi1. As you can see, if we sum these two probabilities, the probability of finding spin up with the probability of finding spin down, we get 100%, which totally makes sense since we have only two possibilities. Now, moving on to our next quantum state, ket psi 2, given by 1 over square root of 5 ket plus 2I ket minus. The probability of finding spin up is given by this expression, modulo squared of this inner product. I will start by calculating this inner product and then plugging back the value found on this expression for the probability. So here we have a bra plus that multiplies 1 over square root of 5 bra plus 2I over square root of 5 bra ket minus, if we multiply here, we know that the first result here gives us 1 over square root of 5, and the second multiplication gives us 0 because ket plus and ket minus are orthogonal. Then if we plug it back, we know that the probability of finding spin up is given by 1 over square root of 5 squared, which is 1 over 5. That's the probability of finding spin up. On the other hand, if we want to find the probability of getting spin down, in a similar way we have this expression, the modulo squared of this inner product. Let's calculate this inner product then, and we have 1 over square root of 5 ket plus 2I square root of 5 ket minus. So here we have the opposite. If we multiply here, the first term gives us 0, the second term gives us 2I over square root of 5. Then the probability of finding spin down is given by the modulo squared of this value, which is 4 over 5. That's the probability of finding spin down if a measurement is made on the quantum state ket psi 2. Now moving on to our last quantum state, ket psi 3 equal to 1 square root of 10, 3 ket plus minus exponential I pi over 3 ket minus. The probability of finding spin up, I will skip some steps here and I'll go direct to the point. The inner product that we have to calculate is this one, and if we do the calculation here, you will find 3 over square root of 10. Then if we plug it back to the expression for the probability of finding spin up, you will find 9 over 10. That's the probability of finding spin up. Similarly, the probability of finding spin down, we have to calculate this inner product first. So here we have exponential I pi over 3 over square root of 10. So if you plug it back to that expression for the probability of finding spin down, we have the modulo exponential I pi over 3 over square root of 10 squared. So here we have a complex number involved. The modulus squared of a complex number is defined by the complex number times its complex conjugated. In this case here, it will give us 1 over 10. That's the probability of a finding is pinned down if a measurement is made on the quantum state ket psi 3. What we can observe by looking to these results is that the higher the coefficient that comes with the ket, the greater the probability of finding that ket if a measurement is made. That's all for this video. Thanks for watching. Bye for now.